This is Dr. MSNA Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, potential and what is potential, how we can define potential, and electrode potential. What is the electrode potential and definition of electrode potential. Next, single electrode potential and Nernest equation. So these are the topics we are going to discuss. First, coming to the potential. So what is potential? Potential is nothing but energy. So that energy used to either gain or lose of electrons. That means, suppose if we take some matter, that matter has ability to either gain or lose of electron. That is known as potential. So usually metals are act as a electrodes, either anode or cathode. So the tendency of a electrode to either gain or lose of electrons is known as electrode potential. So simply we can call it as potential is the energy which is associated with electrode to either gain or lose of electron is known as electrode potential. So let us see how we can explain the potential concept by taking some electrodes. So here, when a piece of matter is placed into a solution containing its own ions, a potential difference exists between the solution and matter. So that is known as electrode potential. The potential difference is known as electrode potential of the matter of this single electrode system. So here we can see, here some zinc metal I am going to place in its solution, that is ZnSO4. Zinc which is dipped in solution of its own ions, that is ZnSO4. So after some time, zinc acts as a anode and loses electrons when it is contact with its own solution. Initially zinc is dipped in their own solution of ZnSO4. After some time, zinc slowly loses electrons. Why? Because the nature of zinc is anode. It has anodic nature. So that's why oxidation takes place on zinc. So gradually zinc releases electrons and comes into the solution as a Zn plus 2. Zn plus 2 by leaving negative charge on behind. So the electrode will become negative and Zn plus 2 comes into the solution as a plus 2 ions. So these Zn minus 2 ions neutralized by passing Zn plus 2 ions from solution to electrode. So here we can see that inside of the electrode contains negative charge and outside of the electrode contains positive charge. So similarly, one more electrode I am going to take, that is copper electrode. The copper electrode is placed its own solution of copper sulfate. So after some time, copper gains electrons. Why? Because the nature of copper is cathodic nature. So it has cathodic nature. So that's why reduction takes place on the surface of cathode. So it gains electrons from copper sulfate solution. So this electrode potential depends on concentration of ions present in the solution, and nature of metal electrode, positivity of nature, and temperature of the solution. So each electrochemical cell is made up of 2 electrons. At one electrode, electrons are evolved, and at other electrode, electrons are consumed. So each electrode dipped in its solution called half cell. The potential of half cell is called single electrode potential. So electrochemical cell is made up of 2 half cells. One half cell acts as a anodic compartment and another half cell acts as a cathodic compartment. So each electrode is dipped in each half cells. The potential of half cell is called single electrode potential. So here we can see the ZnSO4 salt beach, copper sulfate and copper. So ZnSO4 is the one of the half cell, and CuSO4 and copper is the one more half cell. So this is the cell representation. Next, definition of standard electrode potential. Electrode potential measured under standard conditions. That is, concentration of solution is 1 molar and temperature is 25 degrees centigrade. The potential of a electrode at standard conditions is known as standard electrode potential, which is denoted with E0. So that is the ability of the electrode which either gain or lose of electrons at standard conditions, that is concentration of its own solution 1 molar and temperature is 25 degrees centigrade. So that is also known as standard electrode potential. So it is measured against standard hydrogen electrode as a difference electrode, which is assigned a potential of 0 volts. Standard hydrogen electrode potential is 0 volts. That's why we can say that acts as a reference electrode. Next, coming to the EMF. So what is EMF? How we can define EMF and what is the use of EMF? So during oxidation and reduction reactions in a cell, some potential difference will be rises in between the 2 electrodes. The maximum potential difference between 2 electrodes of a electrochemical cell when no current is flowing is known as EMF, electromotive force. So it represents the driving force that pushes electrons through the external circuit. Essentially, EMF is the voltage generated by a cell or battery due to the chemical reactions inside it. So during the chemical reactions, potential difference will be generated in between the 2 half cells or 2 electrodes of electrochemical cell. So that potential difference is known as electromotive force. Electromotive force is measured in volts. When the circuit is open, the measured voltage equals to EMF. Once current flows, the voltage drops slightly due to internal resistance. So it is the difference in potential energy per unit charge between the two electrodes. In electrochemical cell, the EMF is the difference between the reduction potential of the cathode and the anode. And we can write the formula for EMF. EMF is equal to E cathode minus E anode. So that is the reduction potential minus oxidation potential. Next, coming to the Nernest equation. So what is a Nernest equation and what is the use of Nernest equation? Nernest equation is a formula used in electrochemistry to calculate electrode potential of a half cell or full electrochemical cell under given conditions. So with the help of Nernest equation, we can find the potentials of unknown electrodes or full half cell, full electrochemical cell potential also we can determine by using Nernest equation. So here what are the standard conditions? 1 molar concentration of the solution on atm pressure or 25 degrees centigrade temperature. So under these conditions, we can measure or we can determine the potentials of half cells as well as full cells, full electrochemical cell. Here we can write the Nernest equation as below. E is equal to E naught minus RT NF log K. The E is electrode potential at non-standard conditions. E naught is the standard electrode potential in volts, and R is gas constant, universal gas constant, and that value is 8.314 joules. And T is the temperature in kelvins, and N is the number of electrons which are involved in the reaction or which are transferred in a cell, and F is the Faraday's constant, that is 96,485 coulombs, and E is the equilibrium constant of the reaction. So that is the Nernest equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.